So we are online. Let's start. Hello,
Yes.
everyone, and thank you for joining us. My name is Vladimir Litvinov. I am Java team lead in EPAM Systems, and I will facilitate today's session. So today we are going to discuss a very disputable topic, and is particularly close, especially to my heart, and it's titled "Learn Algorithms: Why is and there is easy, medium, and hard answers." More especially, we'll explore a key question: is there a practical and applicable reason to learn algorithms today, beyond some abstract self education? And as for me, I want to talk about myself today. I have spent 3 years involved in algorithmic competitions during my school years, and this topic is very personal to me. So, answer to this should be also, consider with this brave new world, like Vyacheslav like to say, it's that it's shaped by Googling, pre-built libraries, and artificial intelligence. So we have professional with us here today. Who is gonna give his answer to this question. It's Vyacheslav Silchenko. Hello, Vyacheslav.
Hi everyone. Hi Vladimir. Yeah, thanks for inviting me today, and yeah, it's good to be here.
Thank you for joining. He's software engineer with more than 20 years of experience. He's driver of lead code algorithms community, and also he is driver of data structure community. And I think that before we jump in, let me highlight as always couple promos, couple important things. You know that all the time you have a chance to ask your questions in the chat, but today we will ask questions also to you and want to see your answers as always via the YouTube or via community chats. So submit your questions and submit your answers. Short promo time. Could we have a look at the presentation, please? And next slide, please. So, as always, promo, if you would like to improve your skills in technical areas, learn Java, enhance abilities in teaching or mentoring, so feel free to join MRC School as mentor or student. It's a great opportunity to grow. One more slide, one more promo. So, if you like to join to our community also as speaker, so just write to this mail or scan QR code, and we would like to hear some interesting topics from you guys. Thank you. And that's all from my part from the start. So without further ado, I'm handing this session to Vyacheslav. Thank you.
Thank you, Vladimir. Yeah, just quick slide about me. Recently, I update these numbers and just surprise to myself that I already 10 years with EPAM and 25 years with industry, working in different areas from consulting to software engineering. And in scope of this topic, this presentation, I'm driver of lead code algorithms and data structure community, which is public link here. So feel free to join. And with this being said, let's jump into our presentation, which just quick reminder how it called. So learn algorithms, why, and we have easy, medium, and hard answers. And let's start with easy answer. Easy because I think it's quite straightforward. We have big five tech companies, which is Aberration Funk, Facebook, Apple, Amazon, Netflix, and Google. Nowadays, it's there is different aberration, but the main point here is that these companies use algorithms problems as a way how they interviewing people and the way how they actually build the interviewing process in general. So it could be easy, medium, and hard problems, and the main flow is basically solve that problem during the interview and discuss the solution, discuss the flow. And here is the first problem. So we have probably the most popular problem in the world, I would say, like two-sum. And I believe initially it was introduced by Google. That's why there is a Google sign here. And let me just quickly read it through the problem. So we have given an array of integer nums and target integer called target. So we need to return indices of two numbers such that they add up to target. You may assume that each input would have exactly one solution. As you can see, it's even highlighted here bold. And you may not use the same element twice. And one note, you can return the answer in any order. So here is the problem. And I guess the first question which we would like to discuss, how to approach that, what we should do first. And one answer to that could be, yeah, let's start coding and do that. It's simple problem, easy, so we can come up with a code real quick. But what do you think about it? Is it right thing, or we should do something different? And let me see the chat and make sure that I am not alone here. Okay, we don't have anything in the chat, I believe, and we don't have Vladimir here as well.
Oh yeah, finally. Thank you.
Okay,
So I will start the discussion. Yeah. So I have some experience in such kind of tasks. So I think that we should start with reading carefully the description of the task. It's great that here we have highlighted this exactly one solution. Not, you could solve the task that it's not really existing, because if we will think about how to solve when there could be solution or couldn't be, it will be totally different task with totally different difficulty. And here we have these highlighted words. So guys, yep, read carefully. Maybe you have some other thoughts what to do first. Should be solved with a map in the linear complexity. We'll talk about it a bit later.
Absolutely,
Yes, we have solutions. The pointers. This guy is more about solution. But if we'll talk in more general way, how to start solving of such tasks as a class, then read. Yes, think about what kind of solution. Maybe you have something in mind from the start, and it's a simple solution. Maybe it's dumb, but it could work. Just think about it. Maybe write some notes and then try to think a bit more. But it's very important not to spend too many time on designing some ideal solution, because it's better to solve task not perfect way than not to solve it at all. Vyacheslav, what else do you want to say?
Yeah,
Intuition.
It looks like we have separate chats, because I can see in this chat from
comments. You can check comment section, private chat, and there is comment section, and we have comment here, ask for examples, boundaries, and so on.
And that, I believe, good call out. Actually, everything what was mentioned in different chat, what I was trying to raise before.
There is also great comment, go through the examples and think about edge cases.
Okay, yeah, we have we are community. I thought that this chat's connected, but doesn't matter. So yeah, and thanks for pointing out all this stuff. Personally, I would say that, yeah, read carefully, and I try to do it for you when I read the entire problem. And as you can see, there is something highlighted. As Vladimir mentioned, we have exactly one solution, which is crucial, actually. If it's not exactly, remove exactly one, and it will change the problem entirely. So moving on, the next thing, as someone mentioned, probably many of you mentioned, is examples. It's really helped. If you read like plain English, it's one story. But if you get, okay, we have array like 2, 7, 11, 15, and we have target 9, and we expect output 0, 1. So that makes us thinking, what's the flow? So here from human region, so target 9, so 2, 7. It means that 2 plus 7 is 9, so output is index 0, index 1. And that could be one of the question. And I'm not sure if anyone mentioned questions, but I believe it's also good step while digging into the problem. Usually it's like during the interview when you start asking the question. And for example, here never mentioned what indices means. Is it zeros starting from 0 or starting from 1? In this example, it's clearly that it's starting from 0, for example. Moving to the next example, we have target 6, so it's obvious that it's 2 plus 4, 6, and output is index 1 and index 2. And in third example, it's just two norms, so it's clearly 0, 1. That's one thing. And second thing, which also crucial, is constraints. Here I provide some quite easy constraints. So length is just 10,000. Each element is between 10 of power of 9 and like minus and plus, and target the same. But for example, this particular problem, which is easy one, can be medium or even hard or even super hard. If we say here, instead of 10 of power 4, let's say 10 of the power of 400, and it's could not be in memory. So we need to come up with some not obvious solution. One of them could be like store all that data in database or some big data or whatever, and that will dramatically increase complexity. But in our case, it's easy problem. We have everything which fits in memory, so we don't have any issues. Vladimir, do you want to add something more on that?
Maybe I will add a couple of comments from your community. So first, draw algorithms. I use paper and pen. What do you think about it?
Oh, that's an interesting point. Actually, it backs pre-pandemic. It brings us to the pre-pandemic world when not most, but quite big percentage of interview was on site, and there was idea coming again from Google when it just white paper, and we address the problem in the way when we just use our hand and draw. And that's an interesting approach. We kind of doing something similar in our community. We don't use any tools, and it's more like simple coding, but we still type it. Personally, I'm quite old guy, so I like that, how to say it, when you take a pen and start drawing, it's fire up brain cells, which is from the past when, in school we do everything like using our hands. But I understand that in like present world, and there is a generation which, like my children, they never use pen. Like they use pen really less, and more typing and all that stuff, like using cell phones. We have communication like a couple of days ago with my child, and he said that, hey, I need my phone because I'm like connecting to my friends, and that's entirely new world. So I'm not pushing for that, but personally I like it.
Mm-hmm. There is also a lot of some ideas how to solve the task, like slide in a window, sort array, and then task become obvious. Also, there was a comment that now deleted regarding trying to combine all pairs and so on. So, guys, just small advice one more time: not try to find the solution from the start. Try to understand the problem first, constraints, and so on, because it could be very difficult, different solutions for different constraints. Okay, let's go on.
Yeah, that's absolutely. And in the meantime, I'm trying to get chat. I thought that it's synced, but no problem. So yeah, next let's see what the solution I have, and we can discuss it. And yeah, before jumping into the code, I actually want to highlight another thing. During the interview process, you can ask the questions which we already discussed. But for example, for this particular problem, the question could be, which change the thing dramatically, is it sorted or not? And I have a question to you. We will jump into the code, but I have a question to you all. So if it's sorted, what it will change? But currently we assume that it's not sorted. So we have that nums, and let's see the solution. I prepared two code snippets in two languages, like more than Java. So we have Java solution and Python solution. The algorithm itself is the same, it's just different languages. And I personally more often use Python for solving problems. It looks shorter, and this particular example highlight that.
To win some microseconds in result, yeah.
Actually, in terms of performance, Java is better. But in terms of typing, for me, Python is kind of pseudocode, almost pseudocode. If you remember when some problems, if we go back to the past, when we do like handwritten code, in some cases we just use pseudocode, like not compilable but understandable to human. And the Python itself, as you can see here on the screen, the Python looks very, very clear. Only for loop, which is really different. But apart from that, so what we are doing, and that was mentioned in the chat, so we need to introduce some hash map, and we basically put, we call deltas, and we put where diffs. So we have target, and we have arrays of numbers. So if current number is not in that hash map, we just put target minus that number, and we, as a result, we need to store indexes. So we store I where. And as soon as we got that, so our current number is in hash map. That's it. We just return current index and index which we get from hash map. And that's basically the solution. As you can see in Java, the algorithm itself the same, but we need to do more code, explicit code stuff like map, the result of array of 2. We need to use more ifs, but at the end of the day, the algorithm exactly the same, and we return rest. So that's the solution. Yeah.
So Slava, can you see the chat from your community now?
Let me double.
There is really some interesting comments regarding this task, especially regarding sorted option.
That's cool, but surprisingly, I don't see the chat.
Just open this Via community event and press play, and then you will see it.
Okay, I need to join.
Yeah.
Okay. Oh my goodness!
We didn't expect that there will be so much answers, so it just will be. We'll spend too much time if I will read all of this aloud. So it would be great if you'll join.
Yeah, I got it. Yeah, thanks, and thanks all. Thanks everyone for jumping in and put all your comments. Yeah, so
get range from 0 to target and sort only it. What do you think about it?
Okay, it's interesting. And that's actually, even if it's not sorted, we can basically sort it by ourselves. So that's the solution on the screen. and we are kind of moving to the next topic of the complexity. The solution over screen is quite efficient, but it has a drawback. And probably we can talk about it in the chat. So, guys, what do you think? What's the drawback of the solution which we come up currently?
And let's also compare it with binary search, if it's sorted. After it, when we will speak about complexity. So we have memory answers.
Yeah, exactly. That's the main drawback of it. We have space complexity, and as soon as we already introduce the term complexity, and that's actually interesting. I usually start from computation complexity, but we can start with memory. So what do you think, guys? What's the complexity here in terms of big O notation, if you're aware? If not, it's fine. I'll cover it later on. I can see ON plus O log n. Any other thoughts on that? Space and time, both ON. And third one, space ON. Yeah, and personally, I think it's big ON, given that we have extra hash map, which is at worst will contain all elements, and all elements nums is usual size is n. Yeah, thanks for your answers. So we cover that, and hash access is considered O1. Yeah, it's good question, and the answer is yes, but it's required to go deeply into the organization of a hash map. We will not do it like very deep, but at a high level, there is a like two. So what I'm trying to say that in most cases, and there is amortized complexity, and in that case it will be of one. But in some cases it could be bigger, and that require. There is a big topic on hash map. Actually, it could be even separate presentation how it's organized, what we have, and what's difference during the if we are talking about Java. What's difference behind the hood on the hash map in different versions of Java. So you can dig into that, or probably some of you, some of us can come up with that presentation. But in short, yes, of one. So
Average, yes, is constant.
Yeah, amortized of one. So that's, I believe we cover. And returning to the sorted thing, we can consider implementation to make it even without extra memory. And that's quite interesting approach when we use, for example, 2 pointers. I'm not sure. I think I've seen slide in window, but not sure how it can be applied. But yeah,
I believe it was the answer with 2 pointers, yes.
Yeah. So yeah, 2 pointers can dramatically improve the thing. So we will get ON time complexity and O1 space complexity. But as soon as it's not sorted, we need to sort it. And given we have in the chat, so let's come up with complexity in that case. So if we need to sort it first, and after that apply our algorithm with 2 pointers, for example, what the complexity of that solution will be.
Quick sort complexity. What is it?
Yeah, for example.
Okay, it's n log n,
Yeah.
yes.
Yeah, we got
Right, guys.
a couple of answers. Yeah, thanks for that. And that's actually give us the example of when we need to mitigate what's more important to us. As we just seen, we can have time complexity ON and space complexity ON. But if we sort it by ourselves, or we don't change the problem remains untouched. We can go with time complexity n log n and space complexity O1. And as someone mentioned in the chat, in most cases, we more care about time complexity than space, but there are some cases when space is also important.
And small comment to guys who want to sort from the start, just a small advice. If you'll be on interview or just trying to solve such task, just sit a couple more minutes and maybe you will find this second more ON solution. Yeah, it's good option too, but it's better. And I believe that you can find it if you will think for additional couple of minutes. Not start writing the code. That's the rule.
Yeah, very good point. And that's actually covers what to start. And in most cases, the easiest answer how to come up with how to approach is not jumping into the code, as Vladimir just highlighted. So first, think, ask questions, check the boundaries, and discuss the problem and solution, and only after that go and jump to the code.
Mm-hmm.
Okay, sounds like we cover easy problem.
Small question from me. So here you have used HashMap, and to have HashMap, you need to use some language. You have to know how this data structure works, and we know that you are lead of data structure community. So my question is, how do you think what top 3 most important data structures that are used for solving of algorithmic tasks?
Yeah, thanks for the question. I would say HashMap, and HashMap.
Okay, let's try to distinct. That will be one.
Let's say that lists is quite a crucial data structure, both array list and linked list. HashMap, as we just discussed, it's probably the first. And simple arrays. Simple arrays solve a lot of problems, and we will, in a few more minutes, we will jump to the next problem, and we will see arrays as well.
Yeah, and don't forget about linked lists, guys. For tasks working with graphs, they are very useful. Okay, thank you.
Yeah, thanks a lot. And yeah, regarding linked list, that reminds me that one of the most popular questions on Java interview, what's the difference between array list and linked list?
Yeah, it's just to understand, can the person explain something? It's not about truly difference on linked list and array list.
Yeah. So moving forward, that slide, represent complexity, which we already covered a bit. Just want to highlight that when you come up with some solution, the next step is to check your time and space complexity. That's kind of wrap up notes on the particular solution. And for example, you, as Vladimir said at the beginning, you come up with something which is not efficient. Let's say O(n) square or n factorial or whatever. But yeah, it's working solution. It's not efficient, but you know the complexity. You can describe it, and after that, you can taking that as a starting point. You can think about some more efficient solution or way to optimize it. And as we just discussed, it's apart from time complexity, space complexity in some cases can be important as well. Okay, with this being said, let's move on, and we have medium answer, which for me is brain development. And here is where I would say kids problem, and I would like to see the answers. So feel free to come up with a number in the chat. So we have that parking lots, we have some numbers here, and what's the number under the car? Okay, we have three answer, even four. Yeah, thanks, guys. I guess that's the right one. What I remember from that book, it's you need to read it from opposite direction. So 1606, 68, 88, 98. You don't see any sequence, but if you rotate it, it's 86, 87, 88, 89, 90, and 91. And personally, when I first time seen this issue, what was not clear to me, to tell you the truth. It was not that easy. And I can see actually another one. Okay, 86. It's explanation, yeah. Thanks. And what I'm trying to jump into here, that as soon as you solving the algorithms, you basically develop brain cells and improve your ability to solve more and more complex problem. So let's see our medium problem. So we have 2D binary grid M by N, which represents a map of ones, which is lands, and zeros, which is water. And we need to return the number of islands. And the name of a problem, number of islands. And so the definition of island is surrounded by water, is formed by connecting adjacent lands horizontally or vertically. So you may assume all four edges of a grid are all surrounded by water. Yeah, that's problem from Amazon interview. So the general questions, how would we approach? What's our first steps starting digging into this problem? Let me open the chat.
It's a very general situation when you can't understand fully task description before you will take a look at the examples. For me, for this task, it's working like that.
Yeah, I agree. And I can see in the chat that a lot of people talking about DFS, BFS. Yeah, that's two things. But yeah, that's I would say that it's right thing. And actually, DFS and BFS is, I believe, most valuable algorithms. It can be used in solving a lot of problems. So if you're not familiar with these two algorithms, I would suggest to dig into that. We will look at the solution and talk more about, I think somewhere it was mentioned recursion. But before what Vladimir said, again, let's start with examples. And here's the examples. So we have a grid, and as you can see, it's just simple two-dimensional array with ones and zeros. And here is the output one, so we expect to see just one island, and it is this. I could not draw here, but I hope you can see my mouse. So these ones in combination create island. And in second example, it says free. So we have here one island, that's another, and that's another. And this is because if we read it carefully, and again, we returning back to read carefully the problem. So we have definition of island and lands connected by connecting adjacent lands horizontally or vertically, and nothing saying about diagonally. That's why this one is actually another island. And the constraints, as usual. So if we have that grid, let's say, like not fitting into the memory, DFS and BFS would be not so straightforward solution. But in our case, it's still medium problem. So in our case, it's just 300. So it definitely fits in memory, and we can consider DFS or BFS. Yes, most of you, a lot of people mentioned here. Okay, before jumping into the implementation, Vladimir, do you want to discuss more on that?
No, I think that we have pretty good answers, so we can discuss the solution.
Sure, yeah, and thanks, guys, for actively participating in the chat and providing your thoughts on that. Yeah, really appreciate it. So here's the two solutions, again, Java and Python. And as some of you mentioned that it could be BFS, and that's totally true. Personally, I create here, I didn't name the function specifically DFS. It's called Mark Island. But if you look closely, it's pure DFS function. And what we are doing here, basically iterating over entire grid, and if it won, so we consider it as island, we mark island and increase result by 1. So it's we have found at least one island. And I do the trick here, which some people think that it's not allowed, and that's one of the topic which you can always discuss during the interview. I'm updating the input. So in real life, don't do that. It's when you get something, don't change it without any like strong reasons. But while problem solving and to make the code more elegant, what I'm doing here is in Mark Island, I'm mark each like island pieces to water, and at the end I will get all zeros and number of islands. And as you can see, and some of you mentioned, we are using recursion here. So it's simple DFS implementation when we have to move to each direction, like as we discussed, diagonal is not allowed, but we can go like up, down, left, right, and that's represented with 4 function calls. And we have recursion condition to stop digging into that. And out of bounds function is just helper function in Python. In Java, it's slightly different, but the idea is exactly the same, as you can see. Okay, let me switch to the chat to see.
We don't have updates there. You know, maybe it could be an option to mark not as 0, but mark as, for example, 2, to don't miss the data that was already processed, and just modify if statement. And then for the bucket, it will be more obvious if you will just try to find some corner case in your solution. That will be a bit easier for you, and it costs you nothing.
Yeah, that could be one of the approach. Instead of just mark everything as a water, we can mark it as some different, and modify our condition here to see if it was, for example, water or wet marked.
Or just not one. Yep.
Yeah,
Not
definitely.
island.
One. And another thing, talking about BFS, and actually different implementation of DFS. This one is probably the most simple one, using the recursion. But if we are using, for example, BFS and we use queue, in that case, we will need to have some visited set, and that will save us of doing any changing of input grid. We can update that visited set and basically edit it there, but it will, of course, introduce space complexity. Okay, I can see some updates in our chat. Okay, yeah. A modification of what you, Vladimir, proposed, like -1. Yeah, -1 could be also an approach. Okay, so here the topic which we have not covered yet is recursion. And I would say, yeah, what do you think, guys, about recursion? Is it a fine thing to do, especially in production?
After go to operator, it's the best solution. For me, I'm just afraid of recursion in production code. It's hard to read, hard to understand. Yes, and as mentioned in the chat, Stack Overflow could be your friend for some time.
Yeah, Stack Overflow is a good example, and that's possibility to get it. The good thing about most of algorithms, I would say every, but not every time it's really simple. We can avoid recursion, and for example, for DFS, we can use either queue or stack. And in general, actually, when we have a recursion, under the hood, there is a stack. That's why we actually get Stack Overflow. But what we can do, we can use our own stack and introduce that data structure and use it as a controlled stack, not Java or Python stack or whatever. And but from performance perspective, actually, one more thing. Talking about memory, here, as you can see, we don't have any extra memory data structure. So what do you think, guys? Do we have all one here, like memory complexity? Okay, we have vote for all one. Any other thoughts on that? They're using the stack. Good point.
Let's go with that.
Yeah. So that's very valid point. As soon as we are using the stack, actually, memory complexity would be the dimension of this matrix, so m by n at worst. And what about time complexity? And actually, when we have recursion, it's not, in most cases, it's not easy to get it. But what do you think, guys? What's the complexity here? Let's just use probably 10 seconds for votes. Feel free to provide yours in chat. And square, yeah, and by M, yeah. Thanks for your participation, and I guess we cover everything here. So let's move on.
Before we'll dive into the hard answers, I want to summarize. So just simple, easy answer to pass interviews. You need these algorithms for this. Yep.
Yeah.
And second, to do brain development that could be practical because you are training your brain and you can use this more powerful brain in your daily activities and in daily work. So, but my question is, in our AI world, we have, this Googling, we have ChatGPT, and we can just copy some task description, even from production, just enter it and work with the result with ChatGPT. So what do you think about it? Maybe we don't need these algorithms at all. Why are you trying to make us learn all of it?
Oh, that's a very good question. And it's not easy answer to that. I would say that previous two answers is still valid. During the interview, you still use algorithms. For brain development, it's good problems to be solved. And on top of that, I would say that if we are talking about AI in general, under the hood, it's again algorithms. It's even more sophisticated algorithms compared to what we just discussed, and it's a lot of I would say mathematical problems and different approaches, which is even harder than this. But yeah, most of the people don't care about it, and it's always a balance how deep you want to go. And personally, I think that even with AI, we can talk to AI and say, solve that problem and describe a problem. But the good thing that we understand the solution and can first review it from our understanding. And again, to be able to do that, we need to solve some problems by ourselves. And second, we need to, in some cases, or quite a lot of cases, we need to drive AI to the proper solution. So it's not like you give AI the problem and you always get the right answer immediately. You need to talk to it, or him or she, whatever you prefer, and do it in several iterations. I know that it's not like covering everything, but that's my feeling about it.
I want to add something that, in some previous years, maybe a Stack Overflow could be a solution for each task. You just write in some question and you get an answer. We have Google and now we have these AI tools. But guys, just a tool. If you don't understand the result, maybe some guy on Stack Overflow will write you and some comments that will just format your hard drive and you won't be able to understand it because you know nothing about computers. And same for it. If we're working with some production code with algorithms, you have to understand the result. Sure, it could save you time, just do some routine for you, but you can't make AI responsible for it. So what can you do with ChatGPT? You will throw away the server or what? No, responsible is on you as professional. That's why use those tools as tools, not as silver bullet. That's my answer. Maybe guys, you have some really good ones too. Thank you.
Yeah, I can see something in the chat, and yeah, I agree
That's
with you,
funny.
Vladimir. And one of them, AI may not provide an efficient solution, and that's very good point actually. Because in most cases when you talk to AI, it provides something which is working, but returning back to complexity in some cases, it's really inefficient. And another one which I also like: why bother copying from GPT if you can copy from Solution tab? For that, what I can say that not all problems are already published. And even if you grab some problem and just change a bit the description of it, that will really make ChatGPT or whatever really hard time to solve it. So you will need to explain, because it will always get to that original problem.
Slava, we have 10 minutes left, so let's maybe speed up. We have really great comments here. Guys, just read it in VIA community. Maybe if we'll have time, we'll talk about them too, but let's try to cover our last chapter.
Yeah, for sure. Yeah, and let's jump into the hard answer. And that's actually covered a bit the question which we just discussed. A couple years ago, we established that LeetCode community, and that picture, I really like it. And that's technology which we had in past decades. Like, it was Java EE. Some of you, I believe, remember that. After that, like, everybody moved to Spring, and at some point, most of Java developers just starting to be Spring developers. Now, not now, but later on, it was AWS and all clouds. It was very popular trend, and it's still popular trend when we like trying to move almost everything to clouds. Now it's AI. What will be next? We don't know. But I believe, like, personally believe, and I hope that some of the LeetCode community members believe in it too, that the core of software engineering, and here I put return to the roots, to the core software engineering. So the roots of software engineering is what under the hood. And yeah, I know that, and on this picture, like, learning algorithms and data structure, it's not long term, but still some people interested in it. And what I'm trying to do is to make it more popular and to like advertise it to you guys.
But guys, if you want to join this more popular trends, please join MJC community, as I make promo at the beginning of the session. Spring, Java, clouds, and AI, it's trends now, and we can learn it together. And
Yeah,
algorithms too.
absolutely.
Yeah, it's the foundation, yeah, for sure.
Yeah, the good thing that you can be in both queue. You don't need to choose. Okay, so moving on. Hard problem, and I try to make it real quick, even though it's hard. So, trapping rainwater. Given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. Quite a difficult. So as we discussed, we want some examples, and let's jump into the example. Here it is. With a visual representation, it's much easier. So we have n non-negative integers, which is actually these bars, and its elevation map, and we need to calculate how much water will be trapped after the heavy rain. And as you can see on left and on right, basically no water covered, so we can consider it's like zeros. And calculating this particular example, so 0 here, 1 in this box, 4 boxes here, and 1 here. We don't have any like astronomy's constraints here, so it's normal numbers. So we basically don't care, everything fits into the memory. And how would we approach that? That's a hard problem, but with easy answer. Kind of easy answer. There is several iterations. I'll show you the, I believe, the most simple to be coded solution, but there could be different. And here the idea is, how would we approach, let's say, as a human? We come to this box and see, okay, on the left, we don't have any boundaries. On the right, we have a maximum boundaries of 3. And so here is 0, here is 3. So as soon as it's 0, we don't care. We could not trap any water. But for example, for this particular example, on the left, the maximum is 1. On the right is the maximum is 3. But as soon as on the left is 1, so that leveling, we can cover the water at most, which is can be covered the smallest boundaries. And taking that into account, we can basically walk through each cell and calculate how much water is it. The simple approach to understand that is to calculate for each cell that boundaries, and using that we can check the water. But that require extra memory. To mitigate that, we can preserve 2 pointers. And actually 2 pointers is one of the most popular and most efficient techniques, but there are several of them. So here's we can use 2 pointers, and here the solution. I can show both, Java and Python. And as you can see, the code is really simple. What we are doing here, 2 pointers left and right. So we point them to the 0 and the end of the array. So we have while loop, while left and right pointer is not met. And we have 2 level max L and max right. At first, we just set them to the boundaries. So max left is 0. In that case, it's 0, but it's what we have boundaries here. And max right is on the right. And what we are doing is in comparing what's the lower. So in that particular case, max left is 0, max right is 1. So we increase in left pointer. And increasing left pointer, here we have a trick. So we recalculating max left, which is what was before, and maximum with current height. Currently is 1, so it will be 1. So 0 between 1, it will be 1. And we added in a result to the difference between max left. We already know that max left smaller than max right, and we just need to subtract the height. For example, here the max left is 1 and height is 1, so we just get 0, so no increase. But here the height is 0, but max left is 1, so we get 1. And iterating over the entire array, at some point we will get the result. And from right pointer, it's exactly the same, just opposite. We're going from the right to the left, and that's it. That
just small comment. Yeah, guys, if you didn't dive into the solution, you're a fortunate person because you can solve it by yourselves. It's one of the most interesting tasks that I solved ever. I love it really, and you can use LeetCode link to solve it, and it's really interesting. And then maybe you can take a look at the solution or just watch our video, which is I think made understanding of the direction of the solution. But it's really interesting. Try to solve it by yourself if you didn't do it yet. And that's the answer. This is the hard answer, that we are solving it together and discussing it. Yep. I got it, yeah?
Yeah, absolutely. And I can see the links already to the LeetCode. I'm not sure about this particular solution, but we did investigate a lot of problems in LeetCode community as well. So yeah, and yeah, feel free to come up with some solutions as well. And that's basically it. To speed up and conclude things. So from my point of view, like 3 things: fun, brand development, and community.
Yes. And I want to add regarding the community, and brain development, that in general, guys, you know that we have to train our muscles to stay in shape, especially after some age. And same is fair for our brain. And it's not question about, you know, some self-development. It's question about fighting with self-degradation. That's why we need such things. Yeah.
Yeah, absolutely. That reminds me that Alice in Wonderland, like to stay on the where you are, you just need to run, and to move forward, you need to run twice fast.
We have, let's do a couple of minutes. I didn't get it right. So do I get it right? That there is no reason to learn algorithms to use them in production. What do you think?
Oh, it's good question, and it depends. Depends what production you have. If it's like more JSON development, in some cases it could be production when you just write JSON. Most probably, yeah, you don't need algorithms. But in some cases, it could be, especially when we start talking about complexity, both time and space, and it require quite a lot of data to be processed, and you need to come up with some efficient algorithm. Or you maybe have like really a lot of data, and difference between n log n and then square for you, it's dramatical. In that cases, algorithms can be very, very beneficial in production. Even if you don't write by your own some implementation. For example, in Java, there is like, for example, sorting. It's n log n, as we just discussed, but depends on the implementation of sort, and that's actually another interesting topic. Like, for example, depends on which data structure you're using. It could be used merge sort under the hood and quick sort. But like one point to at least get understanding in algorithmic, in simple problems. In more complex problem, you may want to not use the default implementation what Java gives you or any other language, but some custom which is more efficient, more performant, because it uses some, for example, just int type. You just need, for example, hash map with ints, and it could be improved. The algorithm could be improved dramatically, and so on and so forth. So it's not 100% answer. It's always like depends on your production.
Yeah, okay, thank you. Let's have next slide and wrap up the session.
Sure, and Vladimir, back to you.
Yeah, guys, announcement of next event. We'll talk about Algolia as Elasticsearch alternative. We have a great speaker, so we'll announce date a bit later, but feel free to join. You will enjoy this session too. And also, if you would like to say thank you to our speaker or to our moderator, use Via Community platform and just say thank you. I also put a link to LeetCode community that Vyacheslav mentioned, so you can join it. It's in comments under this event. And that's all. Thank you very much. Thank you, Vyacheslav.
Thank you all. Thanks for joining. Thanks for being with us.
Bye.